In this video, we'll learn about ordinary differential equations and its terminologies. Here's the index in case you're in a hurry. When solving differential equations, we're trying to determine an unknown function from prescribed information, which is expressed in the form of an equation involving at least one of the derivatives of the unknown function. So basically, if there is any derivatives of the function we're trying to find in the equation, then that equation is a differential equation. Here's some equations. Pause the video for a second and try to tell if the equations are differential equations or not. An order of an equation is meant the order of the highest derivative which appears. Let's look at some examples. The first equation on the top is a second order equation since the highest derivative is y2 prime. The second equation in the middle is a first order equation because of the presence of y prime. In the last equation, the equation is a third order differential equation because the highest derivative is y3 prime. If a differential equation is linear, it means that the coefficients of y and its derivatives are all consisted of independent variables, which are usually denoted as x in ordinary differential equations. For those of you who don't know what an independent variable is, I'll give you a brief explanation. There's two types of differential equations: ordinary differential equations, which we are learning right now, and partial differential equations. In ordinary differential equations, the function you're trying to find has two variables like y equals f of x. In this case, x is an independent variable and y is a dependent variable, since its value changes as x changes. Now, you might be wondering, wait, I know y changes as x changes, but doesn't x change as y changes as well? Let's look at this function. This function represents the location of an object at a given time. When we're setting up a function like this, it's so that we can observe the movements of the object as time elapses, not how time elapses as the object moves. So, we say that the movement changes as time passes, not time changes as movement changes. Now, pause the video for a second and try to tell if the following equations are linear or nonlinear. Moving on. Here's a method to tell if the differential equation is homogeneous or non-homogeneous. Put everything that has to do with y and its derivatives on the left side and everything else on the right side. If the right side is equal to 0, then that equation is homogeneous. If it's not equal to 0, then that equation is non-homogeneous. Again, here are some practices. Pause the video and try to tell if the equations are homogeneous or not. Now, using everything we've learned, try to tell the full name of the two equations like the one I did above. Thanks for watching. If you didn't get it right the first time, it's okay. I know I didn't. Remember, you can always go back to the index and check the parts you found tricky. And so, thanks again for watching. Have a good day.